All right, folks, so this is Schatz, and we're going to take a look at the remainder and factor theorems. Here's our quadratic right here, and it says, what's happening when x is a 1? What is my y value? Where's my graph? Well, if I plug in a 1 here, 1 squared is 1 times 4 is 4, and 1 times 3 is 3 minus 2, and we're going to get a 5 right there. Now that wasn't too bad. When we synthetically divide, again, we want to make sure this is in descending order, 2, 1, and 0, which it is. We're going to write down our leading coefficients, and now we draw our line, and what goes in the box? Well, it's the opposite of this, as a 1. We always bring this first number down. 4 times 1 is 4. We're going to get a 7. 7 times 1 is 7. Add, and notice what our remainder is, a 5. Do you see how this answer and that answer, it's just like plugging it in. And if you get to something like this down here, it's going to be a lot easier to synthetically divide. So let me pull this down a little bit, and we'll do that. Plugging a negative 2 in here and cubing it, that gives you a negative 8 times 3 is negative 24. We're going to put a negative 2 here, square it. We get a 4 times 8 is a 32. And negative 2, that would be a negative 10 minus 7. And that's going to equal a negative 9. So this cubic, when you graph it, when x is negative 2, my y value is negative 9. I really do think that was a lot of work, but let's synthetically divide. Check the order, 3, 2, 1, 0, we're all good. Write down the leading coefficients. And notice we take the opposite of this, put it over that coefficient, we get a negative 2. Okay, always bring down that first number. 3 times negative 2 is negative 6. We add, we get a 2. 2 times negative 2 is negative 4. Add, you get a 1. 1 times negative 2 is negative 2. Notice what our remainder is. Again, same thing as if we substituted a negative 2 in place of all of these. I think this method is a lot easier than plugging in a negative 2, cubing it, squaring it, and that type of thing. All right, so let's go down a little further. And if we would happen to get a 0, then we would know that this would have gone into this evenly. And that's all that this box is saying. All right, so we're going to go on to our next page here. And again, we'll quickly substitute in a 5. So 5 squared is 25. Times 3 is 75. 5 times 7, negative 7 is negative 35, minus 40. Notice we're going to get a 0 there. All right, so check our descending order. Everything looks good. We got a 3, a negative 7, and a negative 40. Take the opposite of this. That's what goes in our box here. We draw our line. We bring down our 3. 3 times 5 is 15, we're going to get an 8. 8 times 5 is 40. And again, our remainder is 0. That means that the x minus 5 is a factor of this. It went into this evenly, and 5 is a root. 5 is a solution. So that's what it's saying in our box. When we get a 0, we know that what we were dividing by is a factor. Is a factor. All right, well, let's look at this next problem here. And in this next problem, they tell us what we need to divide by. So check our order first. 4, 3, 2, 1, 0, good. We write down our leading coefficients. And we're going to first divide by a positive 2. And notice what happens. We bring down the 2. We end up with a 0, which means x minus 2 went into this evenly. All right, great. Now, this part here, this right here, since this was x to the fourth, dividing by x, this now becomes x cubed, x squared, and an x, and 9 is my constant. There it is right there. That is called the depressed polynomial. So this is the quotient. That is called the depressed polynomial. And it still may be factorable. So now we're going to take our second divisor that they asked us to divide by and do it on the depressed polynomial. Right here is that depressed polynomial. So let me scroll down a little bit. And notice what happens. We bring down our 2, and we get a remainder of 0, which means the x plus 3 is also a factor of this original equation. And now since this is, there it is, x cubed, since this is x cubed, we divided by this x, this now goes down by 1, x squared, x, and there's my constant. So this was our depressed polynomial. We did the x plus 3, divided it into it. It went into it evenly. We can see we have a remainder of 0. And now this depressed polynomial may be factorable. There it is, may be factorable. And if you notice, this depressed polynomial here, degree 2, we can play tic-tac-toe or A times C, rewrite B. Notice it factors into those two right there. And now we actually have all 4 roots. X minus 2, x plus 3, 2x plus 3, x plus 1. You may use my shortcut and take the opposite of this, put it over that, we get a 2. There it is. Take the opposite of this, put it over that coefficient, we get negative 3. There it is. Take the opposite of this, which would be negative 3 over 2. There it is. And take the opposite of this and put it over that, and we get a negative 1. So these numbers right here represent our roots. And that's what you're going to do in today's lesson. You're going to be finding the roots, as well as all of the factors. These are the factors, these are the roots, and that's what you'll be doing in today's lesson.